Welcome back to our system design series. Today we are going to explore an important concept in system designs, um, partition tolerance. If you have heard of the cap theorem, you will know that partition tolerance is one of the three critical properties that distributed systems must consider alongside consistency and availability. So, what is exactly partition tolerance and why you cannot avoid them? In simple terms, partition tolerance means that a distributed system continues to function even when there are network partitions. A network partition occurs when parts of the system can no longer communicate with each other due to issues such as network failures or broken connections. These partitions can divide the system into separate groups of nodes that cannot share information, which is a common challenge in distributed systems. So imagine you have a system with servers spread across different locations. Okay, let's say that we have a client and this client sends requests to our system, and our system, let's say our system, and this our system basically is has a lot of different servers. It's basically it's made from a lot of different servers that beans that which are being spread out a lot with sorry, I lost my word. So let's say that it's a lot of we have a lot of servers that been spread out across different or multiple locations right now in the system. Let's just try to make it like that. No, 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 no. What is this? Why? Wait a minute. Oh, sorry. Oh, that's good. So imagine you have a system with servers spread across different data centers around the world. If the network connection between some of those data centers is disrupted, you end up with a network partition. Partition tolerance means that even if some part of the system cannot talk to each other, the system as a whole should still continue operates at least at some extent. So let's say that we have as our client from Germany sends requests to the system, and the system will put them in our data centers, which are from Germany. And all of these servers or all of these systems has connecting with each other to exchange data and replicate data and stuff like that. Let's say the server 2, which is a server in France, cannot connect anymore with the server 3, which is as a server to Germany. So if our system has a partition tolerance, that means it cannot it sorry partition tolerance, that means that if some parts of the system cannot talk to each other, the whole system should still continue operate. So even if the system in the Germany cannot talk with the system in France, we still can the server in Germany can still work and talk and basically serve the people in Germany. So in context of cap theorem, a distributed system can only guarantee, as we said, that two of the three properties: consistency, availability, and partition tolerance. And in the next video I will talk in context and in the cap theorem in details, but let's just put this in table. Like, since network partitions are inevitable in distributed systems, and most systems must partition tolerant to some degree, this means they need to make a trade-off between consistency and availability during partitioning event. You can either ensure that all nodes remain consistent, which may require temporary sacrificing availability, meaning some requests may fail, or prioritize availability, which might lead to inconsistency in data until the partition is resolved. So a great example to think about is a globally distributed database like those being used by e-commerce platform. If a network partition occur between regions, maintaining partition tolerance ensures that users can still make purchase even if some regions are temporarily disconnected. However, depending on the chosen trade-off, it might mean that inventory counts are not perfectly synchronized across all data centers until the partition is resolved. There are a lot of strategies to design for partition tolerance. One common approach is to use eventual consistency, where the system allows some temporary inconsistency, but guarantees that over time all nodes will cover it basically the same state. Another approach is to use replication, and we will talk this in a bit in the future, like replication across multiple nodes, ensuring that each partition can continue to serve requests independently until communication is restored. So partition tolerance is a crucial because network failures are inevitable in large distributed systems. Designing for partition tolerance means that your system can handle these failures gracefully and continue to provide service to users, even under imperfect conditions. The real challenge is finding the right balance between availability and consistency to meet your system requirements during partition events. In upcoming videos, we are explore more about how distributed systems handle network failures and different ways to maintain partition tolerance. And also in the next video, no, sorry. In the next video, I will talk mainly on the cap theorem. Maybe the video after that we'll talk about how to handle network failures. So yeah, if you like this video, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you guys in future programs.